Thank you for coming. Last session of the day, I think. Is it? A lap around Windows Azure AppFabric. This session, for everybody who's watching the session offline on the MS TechEd site, this is all going to be beautiful and you don't have to worry about this. For everybody who's in the room right now, the timing is a little odd because we already had a session, a deep dive on access control, and we already had a deep dive on the new capabilities of Service Bus before this. And this is kind of the introductory summary session for all the code that's in AppFabric, a lap around. I'm going to show you a tour with code of the features that we got, including cache, including some new things that we're really showing for the first time in that detail today. We've been showing some things in an earlier session, and but I don't want to tease that also or tell too much because Jürgen sits here and is going to talk about the application management pieces in AppFabric towards the end of this talk. So let me motivate from a developer's perspective. Hari, our GM, has done a little bit of that from a strategy perspective already in an earlier session. Let me motivate why we're doing those things, and then also from a little bit from a business perspective, really from looking from the ISV standpoint. So if you go and see all the wonderful demos on server technology, one pervasive theme is it's 4 lines of code, right? It's only 4 lines of code. Just insert this snippet, write this line of code, compile, ship. It's sufficient, right? And what they mostly for web apps, and most of us are writing web apps and one from the other. Also, building those apps from an architecture perspective is pretty trivial. You have a browser, you have a web server, you have a database, and you're done. And it's super easy. If you get more clients, they put more web servers in there, the world is a happy place. If you have some session state, okay, then you got to go and put that somewhere. You might put that into the database, or then people might go and put that into some more sophisticated structures, right? But then this is the world as it is. It's very simple. I should be a PowerPoint MVP, by the way. It tends to get more complicated. Let's think about what the browsers are a fairly popular thing, and there's heated competition, which we love, especially we as back-end server people. But there's more apps coming, right? There's apps, like the phone apps, and there's very many of them. And those phone apps don't necessarily have the same requirements as the browser apps. Browser is serving up immediately human consumable content. Apps that are running on the phone have typically different requirements because, and not only phone, but also the iPad and all the other tablets and probably things that are coming out from Microsoft, who knows, will have different requirements because they're optimized for the local experience. If you look at the iPad, it's always a beautiful, wonderfully polished local experience, and it's all local code, right? If you look at Windows Phone 7, it's a wonderful, polished, Silverlight experience, is all local code. All that stuff is local code. Because to do the apps right for the form factor, it turns out you need to have some local processing. And you can just do more beautiful things. Yes, there's HTML5, and that will save the world, and you have all these wonderful experiences you can build with that. But the way the world is going is either HTML for the broad reach things, or it's super highly polished local apps that are very scoped down and, as I call them, ultra personal, right? They do 1 or 2 things really well, and they do that in a very personal way. That requires a different kind of infrastructure. That requires back-end services that they talk to. In the Microsoft world, services are built typically with things like .cf or .f. Did I just lose this? That is amazing. Let's try that again. Do you see that? Awesome. Okay. PowerPoint. Amazing. So I swear it's an F. So you either have WCF or workflow as the backend in a Microsoft solution. We're building great support for REST with REST extensions for WCF. But there may also be an application that's built on MVC, but it's a different kind of app. It's a services backend that you're building. And again, that services backend also needs scaling. And in addition to sessions, it also needs some state very often and more complex processing, especially when you think about the phone and what's happening in terms of multitasking with the phone. For battery, what you need to do on the phone is, well, you need to go to sleep, right? So if you look through all the platforms, Windows Phone 7 or 7.5 then in Mango is going to have a facility how you can switch between apps, how you can do multitasking. It's going to have some limited background processing capability, as I understand it. I'm not in that team. And if you look across the other phone platforms, the strategy seems to be that the best way to preserve battery is not to run. So there's got to be some way you can wake that up again. So for me, phone apps, powerful phone apps, are kind of like an iceberg where the tip is sticking up on your phone, but really everything that's under the water, and that's probably more work and more power, sits somewhere on a server, probably in the cloud, and does all that back-end processing. So there's state that's accumulated on behalf of that little client, right? You want to do processing, you want to keep state, and you want to do back-end work on behalf of that little client. For that, you need to have ways to manage state and deal with state. Then there's this whole notion of authorization, authentication, right? In a separate, broadly distributed world where you have all these different apps and more apps, it would be a sin, we're still committing it, but we're getting better at it, that everybody has yet another password and yet another account, and we're getting tired of it, and everybody is. So the fact that stuff is starting to consolidate on Google ID and Facebook ID and Live ID and all these different identity providers, that there's kind of clusters of consumers around it, and that, for instance, Facebook Connect is taking off, is because people want to keep profiles, but they don't want to keep all that authentication information around anymore. It's just too hard. And you want to easily integrate with those services. Twitter is another one. So whenever I walk up to a website, and I have the option to use Facebook Connect or Twitter or any of those services, I click that button. I don't want to give them another password because I'm tired of it. So you need to be able to integrate that as well in your apps. Then when we think about apps and how that communication link works between them, right? If you have them on a mobile device and you are on networks like the one here, which is actually for TechEd this year, it's pretty awesome. We've seen worse years. So this network here seems very nice. But you know how this is, right? With wireless connectivity, it's not as splendid always. And so you may go in and out of coverage. So how do you send messages reliably, right? How can you build an app where you can tweet something while you're on the plane, and then once your application wakes up again, you're on the network again, why can't that application just replicate that stuff out? Well, because you need to have some infrastructure that has a local component that's a queue, and then that queue needs to be able to talk to another queue. On the way back, that's even more interesting, right? I want to send data to a device into an application on that device that probably exceeds the capabilities of that little notification channel that we have on all those platforms. How do you do that? So you need to have something that you can host, or that probably someone hosts for you, where you can put a message, and you can basically just have a mailbox or mail slot for that device somewhere in form of a queue that device can then come to and get. Or, we're not really talking about devices, we're really talking about people. So where you have items of interest for a person, and where the device, no matter where that person is, can go and get the items of interest as the application wakes up and then walks up to, let's say, an event queue, but that event queue is special, is private, as a subscription for that user. Then we also have the issue of the architectural issue in those simple apps, that the web server may be very busy, but the backend is not scaling for very busy, right? The problem that you have in very many web apps is if you scale out the web tier, you also have to scale out the back end, and that's costing you a lot of money. And often you can't scale out the back end because the back end is limited in terms of resources, because you can't overstress the single database that you have. And for some reasons, you can't easily partition it. As soon as you do any measures in terms of scaling out things, you increase the complexity. So it would be nice if we had additional facilities, additional middleware that helps us with taking that load off, allowing us to do load leveling and load balancing across our backend. And the same is true then for the way back, right? If you put data on a queue, for instance, as it goes to the middle, as it goes to the back end, you need to go but you still need to get back on the same HTTP request. You have an HTTP request that's sending a message into a queue, and now you sit there. How do you get the reply back? There's got to be some facility to do correlation to do all those things. Then you have line of business systems. Let's assume you're building that in the cloud, right? But you have an existing line of business systems that sit on premise. How do you get to those? And how do you get back if those line of business systems sit behind firewalls and NATs? And then you have a wonderfully sharded database and scaled out database with a lot of stuff in it. But you probably want to go and aggregate some of that data from those separate data sources, right? And you got to store that somewhere. You have a complex query that you need to do every once in a while, and you need to go and put that aggregate query result somewhere because you need to have that in a fast way. And you have reference data that you need to show to customers all the time. In select boxes, on Ajax pages all the time. So you want to have that very close by, and you probably want to have that in memory. So all of a sudden, your simple app is not quite that simple anymore. There's a lot of stuff that needs to be built on top of that to turn the simple, it's just 4 lines of code demo into a production app. There's something interesting so that is true, all this is true for on-premise apps as well. All this is true for local apps that you're running, if you're building them in a sophisticated fashion. Now, the cloud adds something interesting here. And that's a business aspect that actually that's important to consider. To illustrate that, let me talk about the traditional way ISVs do business first. Typically, the way how we're doing things is from a customer perspective. If we're selling software, we're telling the customer, go buy the following boxes. So we're sending them $70,000, $80,000, $100,000 back so that they have a blank slate that we can put stuff on. And then we're charging them some software license for the stuff that they put on those boxes. Boxes including licenses for and equipment and licenses for baseline server software, etc. So there's a lot of upfront costs, a lot of upfront investment. The piece of the pie that's for the ISV is kind of that little piece on top, but that's not most of it. Then there's recurring costs, right, which are ISV maintenance fees. That's the lifeline. That's the stuff that ISVs live on. You pay $150 per month, right, to the ISV. It's more, okay. Now, our story here as ISVs is that your income obviously scales with the number of customers, and your margin widens as you can spread that whole R&D cost over more and more customers. So the per customer R&D cost goes down as you have more, and your margin gets wider. So that's a wonderful thing. That's how we do things. Now, cloud is interesting because it adds another pivot to the story. And it is the first time that I can see that computer science or actually hard architecture skills have immediate impact on that model. Because what we're trying to do in cloud, us as much as you, is we're trying to do something to the left side of the picture. We want to make this piece go away. Right? We want to get rid of all the upfront costs. And with that, so we want to lower the barrier of entry and say, hey, you don't need to pay $80,000 to Dell or HP or some other trusted vendor to run my app. No, you can actually go and rent this. And by the way, you don't have to pay anything up front. We're just going to rent that whole app to you. which means that now the ramp-up cost for the customer is 0, right? You can walk up to BPOS or Office 365 and just get an Exchange server. Now, so just as in the previous picture, there's a service operation fee that comes with that, right? So there's something, instead of all these costs, there's something that now the ISV, the now SaaS vendor, is doing, and that's the service operation fee. Now the interesting piece is that for the ISV, there's now platform costs. So we charge you platform cost. You charge the customer some service operation fee based on something that the customer can deal with. Users, right? Something that makes sense, and we're charging you for something that you can deal with, and that's operations on technical things. The goal here and the opportunity is that you can run your apps as dense as possible on as few resources as possible, so that you can drive down your cost with more customers. So the goal is not, so this is the anti-picture to the notion of take your existing software and just put that on 3 VMs, and then if the next customer comes along, take this software and put it on another 3 VMs. Now the goal needs to be that you can put 3,000 customers on 5 VMs. That is the motivation for multi-tenancy. All the Windows Azure services that we build are multi-tenant, which means we run all on shared infrastructure, and we're running all of you on a shared pool of resources. Applications need to do that too, because that's the way how you get there. That's the way how you can widen your margin in that business. Deployment automation, self-healing architectures, auto-scale, high-density, multi-tenancy. That's best practice that we do, right? In our system, we have total deployment automation. We can go and deploy AppFabric, all the pieces, cache, the application management service, service bus, access control, and the whole backend thing with a single command line into a brand new stamp on Windows Azure. Right? It's effectively just one script, and we deploy all those machines, we configure them all. It's all completely fully automated. We're deploying these full environments out of the daily builds, right? Effectively, the daily builds run, and we deploy those environments. The provisioning system that sits underneath our system, that if you put in your credit card and you say, I want to have a subscription, we get notified, and we need to realize this. And if you create a namespace, we create the namespace. That system is super highly resilient. If something goes wrong, the system will heal itself. It has steps to detect failures inside of it, and it will heal things after 15 minutes or an hour, and it's going to get more and more aggressive over time of healing inconsistencies in the system, so that operators don't need to go and work with those things. So, and there's auto-scale, high-density, multi-tenancy, all best practices that we learn as we do those things. So that impacts, the multi-tenancy aspect also impacts your apps. So as a result, it's not that easy after all, right? Building those cloud apps actually tends to be, if you want to do it in an efficient way, it's quite a bit of a job. So there's middleware that helps with those things. And then you have a choice of middleware. There's middleware that helps with all sorts of pieces. So you have middleware that helps with building web services and scaling out web services, and web services also the HTML pieces. There's cache, it's workflow, access control, routing, messages, transformations, and all those pieces. And then there's things you need to do, obviously, under the covers to deploy to the operating system and to the physical and virtual environments. And so you have these config and scaling, and there has been a session today that I've been using the same slides, but this is a different context, a little bit of different context here, so sorry for the repetition. Where you have config and scaling for all of these, and you have management for all of these, and you have program models and tools for all of these. So if you go and if you pull together your tool set for your applications, you can certainly do all these things, but it's a separate experience, it's a separate set of tools, also a separate set of monitoring things for every single one of them. So the goal that we have with AppFabric is that we give you a single family of APIs that are consistent. We give you a single tooling experience, an integration experience, and so that we can give you all these pieces, all the infrastructure pieces, kind of as part built into the platform. In the beginning, as part of Windows Azure, and in the future also as part of Windows Server. And so we give you a way to use web services, a cache, a way to run workflows, an access control system, and we give you a messaging system and integration platform that are part of this. And the great thing is that we're working on deploying and managing all those pieces as one. So you create a namespace, and with that namespace, with a scope, a tenant in our system, you get a cache, and you get an access control piece, and you get a service bus piece, and you will be getting a hosting piece. You get them all together, and they're also getting automatically federated with the access control system, so you have federated access control, for instance, on all of them. And as we go, and we also scale them together, right? So you sit and we host them together, we co-locate them. So you can, if you build it, if you have a cache and we co-locate that cache in the same data center with your app for you. So there's all kinds of advantages to having this all together. So there's 3 places really we have this. We don't talk too much about the appliance these days, not because it's not going away, but you'll hear more about that at PDC. But primarily, the 2 things we target is cloud and box. Box being server and cloud being Windows Azure. All the pieces that we're building today will be available in the server as well. We're just going cloud first. And the reason why we're going cloud first is based on a very simple principle that everybody who's done distributed systems architecture or implementation in the past will know, and that is you can't go small and then go big and still expect your stuff to work. So what we need to do and prove to ourselves and to you is that we can do big, and then we can scale all those things down. Right? There have been epic failures in the past in very many projects, maybe some you're familiar with, I mean personally, where you start out with a desktop kind of application or with a client-server thing, and then you say, oh, and we're going to turn that into a web app or into a distributed app, and you see that all the things you've done for local don't quite scale or are not quite performant if you do them on the wire. So this is an amplified version of this, where if you do things in a multi-tenant cloud environment, it's not necessarily the same thing. So what we're getting with this is tooling for the middleware pieces. We're getting management. So we're getting a common AppFabric management experience across all tiers, and Jürgen is going to show some of that as the result. And we're getting a thing that we currently still call the AppFabric container, which is the basic platform that we run all the services on, and that also your individual services that you can host inside of AppFabric, and that's the new piece that Jürgen is going to show you, where we have all this. So AppFabric, the container, the final name is not done yet, but the application manager is managing those things, and the container is just the thing that things live in. That provides for you and for us the abstraction layer towards the server farm or towards the cloud environment as we have it today. So you'll be able to host code inside of that infrastructure. So with that, so that was the overview. That was kind of the motivation for why we're having all those pieces where we're building them, because we're learning a lot about how to build applications in the cloud, and we know it's hard. So in AppFabric, kind of our mission is to provide you with building blocks that make that building of applications in the cloud and then also federated, sophisticated applications on the server easier. That's the goal. And take all the learnings that we have from building all those services ourselves and to, over time, give them into your hands so you don't have as much work in building those things out. Because it can be fairly complicated if you go and scale up um, um, into large systems, and if you go and build multi-tenant services. So the first question we have, or we're trying to address, is how do you scale your applications better? A lot of apps need a caching layer, right? I mean, there's all kinds of questions, and I don't need to read them all to you. You need to have some caching capability, and really what you need is, for most cases, a two-stage, or at least sophisticated apps, a two-stage cache, where you can have a local cache option, but you can also have a shared cache option that gives you somewhat better perf and easy support for things like serialization as you build your apps out. So you don't necessarily rely on storage to have additional space. So what we have there in that area is Windows Azure AppFabric Cache, a service that just went into production a few weeks ago. So that's now commercially available. And Windows Azure AppFabric Cache is a distributed in-memory cache for apps inside of Windows Azure. The reason why we say inside of Windows Azure is obviously because of latency, because if you're hosting an application outside of the cloud and you're using the cache, then the latency is going to get you. And so instead of sub 10 milliseconds, you're going to get whatever the network latency is, and that's between 50 and 100 milliseconds, and you're not going to be happy with that. So therefore, it's optimized to run inside of Windows Azure, inside the same data center as your Windows Azure apps, and it's designed to be a backend cache for those. It's based on the same technology as Windows Server AppFabric caching. This used to be named Velocity. And so with this cache, you can get almost the same feature set. It's actually the same API, minus a few things that we're currently not supporting yet in the cloud, namely notifications and I believe regions, because they're specific to the server layout. So anything that is really specific to the layout of servers is not yet in there, but the basic capabilities are all there. It's highly scalable, and you can go and dynamically increase and decrease it. We're charging by gates, so there's 128 megs, 256 megs I can show you on the next slide. But you can go and increase and decrease that to your needs, and then only pay the prorated charges as you need it. The way this works is it integrates into local apps as a cache aside cache. So there's no magic going on with right through the database and having this plumbed into the data path. It's a very simple thing. It's effectively a key value store, while this value can be anything that's serializable. There's a single API for server and cloud, and we have two special little APIs: the session state provider and the page output caching provider for ASP.NET that you can easily plug in, and with that you get effectively that support straight away for cache inside of your app. There's another feature for the local cache I'm going to show you in a moment as well how you configure this. And the local cache allows you to not only have the central cache that's sitting kind of as a backplane behind your services, but also to cache objects locally, where you define effectively a TTL for those local objects, and you have those objects don't even get serialized. They just are kept on the side. There's a gate for how many live CLR objects can be there. So you can have live CLR objects in a local cache, and those get written down into the centralized cache, and they get read up. So if you, depending on how you tune your timeliness requirements, you can get much, much lower latency with that as well. So I should do that in the right way. Capacities, multiple sizes, 128K up to 4 gigabyte. Gigabyte, nice. Wow. See, sometimes it gets me with the whole accent business. 128 megabytes to 4 gigabytes. And if you want more, you can have more by pooling multiple caches. So you can use a combination of these sizes to create your desired cache capacity. The pricing is, I don't have the pricing on here, and you have to look up the pricing from the website. The pricing is in the ballpark, slightly lower than building your own cache on a Windows Azure role, because what we're doing here is effectively the most expensive resource in the entire cloud infrastructure is RAM, right? So we're now giving you that RAM. So you have to look up the pricing. But remember what you get out of this. You get reserved, dedicated memory for this, and so that's a little bit different from a regular compute role. So you can increase and decrease the cache capacity dynamically as you need it. If you increase the size, you can do that on the portal. Then the data is preserved and just capacity added. If you decrease it, then the cache just follows its normal eviction policies and just throws data out, but the data is preserved in most cases. So with that, let's go and take a look at some of those capabilities. That also looks like the right client. What I have here is a little sample, and by principle, I'm using the by principle, I'm using the samples from the SDK, so you can follow those samples, and I don't give you any special voodoo. So I've set in the cache API sample, which you find in the SDK samples, I just set my data. I also set my secure key. Did you remember it? Good. And now I can go and add a cache server endpoint. So you already see there's a collection of endpoints that I can add. So the cache client can operate with multiple caches. I put that into the configuration where I'm adding the collection of servers. I'm adding the request timeout. I'm adding the timeout for how long it takes to open the channel. There's a maximum number of connections I can configure. That's a tuning value. If you have a lot of requests from your client, you want to go and make this obviously a little bit larger, but you're going to be hitting some of the quotas. And then there's some transport properties. We don't need to go to all of them. Then here, if you turn this on, if you set the local properties for the cache, you're enabling the local cache up to 10,000 objects in this case, right? With at most 5 minutes lifetime and a timeout-based invalidation policy, which is the only policy that we support right now. But that's how easy it is to create that local cache factory. So you set that cache factory up, and that cache factory will then create out of this a local default cache. And that is the cache instance you want to keep around, because that's the thing that also holds your local objects, right? So it's a client, but it's also a local cache that your objects hang on. So you want to go and interact with that thing, and that's something you want to go and share. So once I set this up, I can, and the sample is something that people with a sense for unit testing will like. That makes it a little bit hard to read. I apologize on behalf of Microsoft Corporation. Well, you can go and have a cache, and you basically just go and add stuff. So you add, and you have a key, and the key is a string, and you add any object. That's what you need to do. That object gets automatically replicated back to the back end, and you're in business. If you want to get it, you get it with that key, and you go and cast it back to what it was. And all that serialization, and whether it's local and how it gets replicated to the back end, is none of your business. Right? That's how easy the API is. If you look at the sample, there are obviously, so if you get an incorrect key, right, then you get a null, and then you can easily go and remove it. So none of that is a surprise. There's additional capabilities like locking and updates, and you can use it kind of like a database with optimistic concurrency control. So there's lock-based updates. So there's all those facilities in that API in a very simple and straightforward way, but that's kind of the core of it. It's just get input, and that's all you need to do. So you need to tell it to create a factory. So this ties into ASP.NET. Here you see an application that has clearly been designed by someone who's working on middle-tier software. I can tell you, we have no skills when it comes to that. UI design, none of our business. So we show, or we're proudly challenged in that area, as we show obviously in the sample. So that's a sample that also goes and ships with that with the SDK. And what that does is it configures this app, this ASP.NET app, to use the session provider. Look how we do on time, not too bad. So this is just adding stuff to the session state. For anybody who's even remotely familiar with ASP.NET, will know what that does. We'll look at it anyways. If the button is clicked, then add stuff to the session. And this is just a built-in ASP.NET session object. And then we're just showing whatever is in the session. So not a big deal. So the magic is here in the web config. In the web config, we have a session provider. It's the distributed session provider. It's just a name. We're pulling that really out of Microsoft.web.distributed cache session state provider. We tried to find a longer name for that, but we failed. And that's all in the assemblies that come with the clients. And then we configured this down here with the cache clients section, which then sets up that information, also sets up a key to secure that data that goes back and forth, because certainly you want to have that cache also protected. So I'll take some questions later, so if you hold on to your questions, that's more productive for everybody. Unfortunately, sorry. So the way how do you get to this island? How do you get to that configuration? We've built that into the portal. So we have a portal that sits at portal.appfabriclabs.com. Let's go get to that. I'm signing in as myself. Now you know my address. Send me email, or don't. I prefer if you don't. Not that I don't like you. Here's my portal. Here's the cache. And in the cache, I have this namespace that I created. And there is a view client configuration bit that I can go to. And that already has for you kind of to go and mark and copy all that you need to go and basically just paste straight into your ASP.NET app. So you can basically just go to the portal for your cache namespace, just grab the config, paste that in, and then comment in, comment out what you need, and then you're basically done with putting it into ASP.NET. So that's fairly straightforward and covers session state as well as output page caching. So cache is a very, very cool thing, and it's the surface area, because the surface area is so small, also very easy to use and of great utility. The next thing, there we go. The next thing is how do we achieve decoupling between services? How do you balance work between workers? How do we integrate with systems on-premise? You had that little box, the line of business system that sits on-premise, and you have a cloud application. How do I get there? Right? But even if you federate across sites, how do I do that integration? How do I transfer messages reliably, transactionally? How do you reach into on-premise systems? Well, the thing we have there is the Windows Azure AppFabric Service Bus. And Service Bus is a messaging infrastructure and relay infrastructure that allows you to go and interconnect sites and services. It provides naming discovery. It provides connectivity with NAT and firewall traversal with an overlay of access control. And since yesterday, announced yesterday into CTP, a full-blown publish-subscribe message-oriented middleware offering with queues and topics. So the new things there, let me just show you something before I show you that other thing. That was the wrong button. That is the right button. So we were just there. Let's go and go to here. So that's the other capability, the relay capability. And in case you haven't seen that yet, that might be interesting. So I have a service that is here. It's a very regular WCF service. So we're using here a image contract. The image contract sits in here. It's using the current REST programming model. It's very simple. If you hit the root of the service, you get to the get image function. And we're just loading a local image, and we're returning that to you. And even though I haven't talked to anybody here in this building, I can go and start this service. I hope. So now I have at HTTPS, let's go make that bigger. It's always fun again. I've been showing this 400 times. If you were to go on your notebook or on your phone to this address, HTTPS Clemens Sandbox Service Bus of Windows.net/image, let's see what we would find. Edit, mark. Let's go get that. And we go to that address. We will find the first employees of Microsoft. Because what I just did here is I just exposed a public web service endpoint, public in the world, that anybody can hit. I turned off the access control integration, just to be clear, from this machine on this stage, right? I can do that from anywhere. There's a video I put up on YouTube. So if you find me on YouTube, I'm Clemens V. I'm Clemens V everywhere. So you can find me on YouTube. On the way to here, I hosted a service from the airport bar in Houston. Exactly that service, and show with a phone how I can do this. So this works anywhere. This also works outside of your data center. So if you have services that sit inside the data center, as many of our customers do, and you want to expose those services into an external DMZ that is Service Bus, you can do that. The thing you do is you change the configuration. You change the configuration file of your services. If you have a WCF service, you have a service you can already expose on Service Bus. You change the binding, and with changing the binding, you now have the ability to go and expose your services on Service Bus, and you can connect, and external parties can go connect to those services, provided they give the right access control token, or you can even turn that capability, that integration off, and allow external traffic in. What you never will get is a raw HTTP or raw TCP socket that terminates into your service. It always is effectively hosted by us, and the traffic is washed by us. We take all the attacks, we take all the bad traffic, and you establish a listener connection to us, and we're listening on your behalf, and then we send that traffic down. But for your services, you won't see any difference. You just take a normal WCF service and expose it with the variants of bindings that we have: basic HTTP relay binding, web HTTP relay binding, and NetTCP relay binding instead of the stock bindings. And with that, you get that capability for your own apps. You can go down the SDK. You can try that. You can host a web service from your kitchen table. Which is really fun. And secret, on appfabriclabs.com, it's free. So for the kitchen table services, that's actually a very cool thing to do. So that was that. So this is the relay. The other capability that we're introducing just now are queues and topics. And I just had a session about them. So you can go to the session catalog and see the detailed session of this. Unfortunately, there's nothing to point forward to. So with these new queues, what you're getting is a reliable, durable storage for messages, sequential store for messages, of up to 1 GB per queue with an asterisk. That asterisk goes in two directions. One is for the CTP, we're limited to 100 megabytes per queue because it's a CTP. And on the other side, so 1 gigabyte is the current thinking. We might be able to go bigger. We may be able to go much, much bigger. It's just a question of scaling this up in the right way and thinking about capacity management in the right way. So currently, we're thinking about 1 gigabyte. We're asking for feedback on whether that's right or not. Queues stay in the system once they're created. So it's much like the file system, much like the experience you have on most of the other services. So they're durable, and you create a queue. There's no renewal. You just create it, and it's there. The maximum message size is 256K. That may seem limited, but we have a feature called sessions that allow you to group a sequence of chunks into a single session, and then also pin them to a receiver. So you can send sequences of messages of chunks around. And we're also looking at layering some magic on top of this, so you actually don't see the maximum message size to be 256K, but to provide that in a way that you get the illusion of streamed unlimited size messages through the queue. And we have 3 APIs. We have the messaging API, we have a WCF API, which means we have a binding on top of this, very similar to the NetMSMQ binding. And we have plain HTTP REST interfaces that allow interacting with the queues and the other features, the topics, using a very plain REST API practically from anywhere and from any platform. Topics provide you all the features of queues plus publish subscribe capabilities with up to 2,000 subscriptions on a topic. And each subscription, that's the core difference, is a virtual queue that's getting message copies. So when I look at this slide, I have a publisher, I have a topic, I have a subscription. This here, that unity of topic and subscription acts exactly like a queue. So you can have multiple concurrent users or concurrent consumers on the subscription, and each gets one message, right? One message goes to either of those. But if you look at this, one message goes into the topic. Everybody, all the subscriptions get a copy. So these are virtual queues that get that message stream. Now those subscriptions can all have filters and actions, and with those filters and actions, you can go and filter into the messages. So I'm going to show you that too. And for those who have been in the sessions in my session before, that's a repeat, sadly. But I think that's okay. What we have here is our little queue sample. Let me just stash all that stuff away here, so we get some more room. So we have a thing called the Service Bus Namespace Client. That's the way how we create queues. Let me go and scroll up here. So we can go and create a queue. And so with this namespace client, we manage that queue. Then we have a messaging factory. The messaging factory is our connection manager, if you will. And from that factory, you can now create a client for the queue. You can create a sender of that client. And then you can go and send. And every issue here is really a message from the message list. And if you want to receive messages, you also create a queue client. You create a receiver of it, and then you can go and receive those messages. There's a number of functions to receive, so there's really not only one. So there's ways to receive, and then there's several ways to go and do that. There's several try-receive overloads with a bunch of parameters, and then there's several asynchronous overloads that are really asynchronous, that execute on the I/O threads. So you have a number of options to receive messages here. And this is a low-level messaging API that we give you. But it's still fairly straightforward, right? There's a sender, there's a receiver. The reason why we split this up into senders and receivers and don't have that straight on the queue client itself is because of allowing you to have code that's the same for topics and clients. So here's a topic. You create a topic in the same way. Now you can go and create subscriptions. We have two subscriptions. We have one main subscription for the agent, and we have an audit tab. The audit tab is effectively just another subscription you just let sit there, and that's logging all the original messages that came in. So you have a topic, you have the agent subscription here, or whatever you call it, is the mainline subscription where all your business data flows. And you have an audit tab that basically just sits on the side where you can now see and observe all the messages, the original messages, as they were going into processing. And you will typically go and drain that into a log. So Again, that is very simple. You have a messaging factory. Off that messaging factory, you create a topic client, you create a sender, you can send. See, that message sender, that function here is the same, really is a message sender and should be. There you go. So it's a message sender, and that message sender will now is the same between queues and topics. So you can make your code that sends messages and also the one that receives messages independent of whether you're talking to a queue or a topic. And then lastly, down here, and I'm not going to spend too much time in that area, but point you to the session recording, is you can go on messages that you publish into that topic. You can create for subscriptions rule expressions, and you can add those rule expressions onto the topic. So you can filter messages out based on the properties that are on the message. So you create a subscription, you say, I only want those messages that match the following criteria, and then you only get those, and so you get a filtered stream of messages, so you don't always get all the messages. So if the input set, the input event stream has 6,000 events per hour, but you only are interested in 2 or 3 of them, you set the filter criteria and you only get 2 or 3 of them. So that's a very, very powerful thing, a very powerful capability that I can't do justice in this short period of time, but something that was certainly worth showing you in this overview form. So that's brand new. We just came out with this. It's a result of 2.5 years of hard work and testing and everything. So this is the first time we're showing that to people, this TechEd, and we're fairly anxious to hear what everybody thinks about those new capabilities, especially as an offering in the cloud. This has existed before in other stacks in similar form. We're not even denying this. We're not saying this is brand new. But certainly as a cloud offering, that kind of capability is certainly something that's new. So that was obviously from a different conference because there's no room Mississippi here. So then access control, still have some time. How do you secure the edge of your system, right? How do you safely federate with other identity providers? How do we deal with the password problem that I talked about earlier? Well, the Windows Azure AppFabric access control service helps with that, and that provides you federated identity. So the sample that I used, if you were in the session with Norm Judah and saw my MartView demo, is using federated authentication, federated identity. So I'm going to show you quickly how I built this, how I did that integration, showing you mostly the pieces in the Windows Azure AppFabric Access Control portal and how that federation works. So I'm going to go back to my laptop. And now I will go to windows.azure.com because I believe I hosted this in the live system, which will not like me. So for this, to show this to you, because I have the live ID cookies, I have to go into the buying your wife a present mode of Internet Explorer. And I will have to sign in because I have special accounts on Windows Azure, and we all do, most of us do, obviously. So I'm going to go into my account and log in for real. So you see that already is built on federation. So in that management portal, these are my real production live workspaces, and I have some of them. And in here, I have for access control, a namespace that is called MartView. So MartView is this little app. Let's go and open up let's open that up here. It's going to work. Martview.net. And let's see what it does. So it shows up at one point in the not too distant future, I hope. It's hosted. But I might be hitting a VM that's just warming up because, a site that doesn't get hit a lot also falls asleep a lot. There it comes. So wonderful. So here we go. And what I do is I say sign up. And to sign up, I just provide these identity providers. So let's go to Facebook. And if I go to Facebook, you see me typing my real passwords. I'm worried. If I go to Facebook, then that throws me back into the portal. And what you see is that actually the name that I logged in with, my address, that's what I use as my Facebook address, has already been taken over here. So these are claims that flow into this application. And I stored that in that app. So now I can go and download the little demo client that I have here. But the point here is that I show you the federation. So in the portal here, I can go to the Access Control Service portal, which is hosted right in your namespace. And let's go and take a look at the identity providers. And the identity providers here are Facebook. And in fact, a concrete Facebook application with my secret and my application ID, which I now have to change, obviously. And so I configure my Facebook app that way. In Facebook, you go to developer.facebook.com. You need to create a new app. They will tell you what the application ID and the application secret is. You put that in here. And they also put the access control address over in Facebook. Let's go and take a look at that very quickly. Developer.facebook.com. My apps. So this app is MartView. And MartView has an app ID, has an app ID key and a secret, and has a site URL. And so the site URL is what you go and configure. And you configure this to be access control. And once you configure this, you basically federate. So you federate Facebook with access control in this way. And then you configure access control with Facebook in this way. And this is how the trust is being set up between them. And now you can go and target any applications that you have against Facebook in here. With Google, it's actually much easier than that. You just say, yes, I want this. There's nothing to configure really except the text. And with Windows Live ID, it's kind of the same thing. So we auto-configure against those. What you can also add is W's Federation identity providers. So anything that supports W's Trust and W's Federation, you can also use here, including Active Directory Federation services. So if I wanted to add the capability for Microsoft full-time employees to go and do this, I could go and add a W's Federation identity provider here, provide the W's Federation metadata here, the document, and then we'll go and import those settings and then set up that federation. But that's something you can go and look at the recordings of a Vittorio session that will show you how to do all those things. Then, with those identity providers in place, we have this application here, MartView. So I'm setting up the realm. I'm setting up the return URL. So I'm setting up this application that will consume now the token. So that's the actual configuration we look at. And then we set up some rules. And those rules then map from the incoming issuers, so Facebook or Google or Yahoo, to a normalized token that I can understand. So I have the output is email address, email address, email address. If I have it from Facebook, from Google, from Yahoo, no matter where that comes from, I'm always mapping to the same standardized claim so that only my application only needs to understand one kind of claim. The way this is integrated into Visual Studio, into the app, not a Visual Studio, into the application is fairly straightforward. So this is the actual app, and we're not going to give you that entire application because it's kind of doesn't necessarily make sense, but we're going to start shredding it apart and put that into demos, into smaller samples. I have the portal here. That's the portal app. And that portal app has a web config. And that web config has, once it decides to load, come on, honey pie. Oh, there it is. So once it decides to load, it has the Microsoft Identity Model setting here. All straightforward code, right? You can type this yourself, but you don't have to, because we have a wizard that is shipping with the Microsoft Identity Model, and that is shorthand for the Windows Identity Foundation. So if you install that SDK, the Windows Identity Foundation SDK, it will extend Visual Studio, and you will get this add SDS reference setting here. And with that add SDS settings reference, what you get is an automatic integration into any Forms Auth enabled ASP.NET app. It's automatic. You basically just point to the document that's given to you by the portal. So the application integration. There's a federation metadata link that's up here. You take that link. You say, this is my URI. You go next. You say, yeah, I want to use an existing SDS. You paste that in here. I'm not going to do that right now. It's going to grab that data and it's going to write the config file, and the configuration is done. Effectively, I encourage you to go to acs.coplex.com and go and get the samples and run through the MVC sample. It will take you no more than 10 minutes to have the full federation set up. It's astonishing. The ACS, the Access Control Service, I believe, is going to do to federated identity, what MTS, Complus, J2E have done to transactions. It's very significant and something you should really, really look at. So we have more tricks up our sleeve. So that was the piece for authorization, authentication. And now, really, the question is, how do you deploy your apps? How do you add resources to scale your app? How do you host code? I believe your machine fell asleep, Jürgen. Let me go and wake that up for you. How do you make your application highly available? How do you address all these additional challenges that I talked about in the beginning? Right? How do we create high-density applications? How can we auto-scale applications? You need to have extra infrastructure for that. We need to have insights into that. We need to have monitoring. And so I'll ask Jürgen Willis, what are you, GPM for WCF? No, for workflow? For
AppFabric.
For AppFabric.
On AppFabric.
Up here and show us the wonderfulness. Let's see. Is that you? That is you.
Great. Thank you, Clemens. Okay, so just to have a few minutes here. How many people saw Hari's overview of Microsoft's middleware strategy session earlier this afternoon? Okay, so just a few hands. So what I want to do here is just sort of tee up a little bit of conversation about some of the work we're doing on Application Manager, this notion of composite application building with Azure AppFabric. We have a session on this tomorrow afternoon at 1:30, where we'll go into a lot more detail in terms of what it means to go build, deploy, and manage composite applications. All I want to do here is show you a very simple kind of walkthrough of a sample application. We'll jump into Visual Studio, we'll see the management portal, and kind of give you a flavor for what we're doing. The simple application here is a benefits enrollment site. So part of the application is living down on premise. That's where kind of the core HR system lives for doing benefits management. There's a workflow that's behind that for managing kind of the provisioning of all the things associated with signing up for a certain benefits package as part of an annual enrollment, for example, communicating with third-party insurance providers and so on. Up in the cloud, I have an application here that's actually where users go to sign up for their benefits. There's a front-end ASP site. The flow through the site is governed by a workflow, integrates with cache for user data, have SQL Azure for some reference data that gets stored up in Azure, communicates via service bus down to the premise backend systems that I have running on premise. So this is kind of our canonical application here. And let me jump into Visual Studio and we'll take a look at what that looks like. Okay, so when I open up VS, I have the app loaded up here. I have the benefits web, that's standard ASP application. That's my front end. Not quite as fancy as the UI that Clemens showed for his sample app, but example benefits sign up, the enroll workflow that governs that flow through the sign up process. A WCF service here that will be used for communicating with the backend systems. Now I have this other application in here, and this you can think about this as sort of the deployment project associated with this application. This represents the overall application definition that's going to be used to deploy the application up in Azure. So if I go ahead and double click on this file here, now I'm getting a description of the overall application. So looking in Solution Explorer, I saw all of the projects associated with my application. I can see those things represented here in terms of here's my WCF service, here's my workflow, here's that front end ASP service, but I'm also seeing now what are the Azure services that I'm using as part of my application. I see, okay, here I have a service bus, queue, I have a connection down to the premise portion of my app. Here's my SQL Azure database, here's my cache usage. If I go down and look at cache, I can see some of the config information associated with that, so I'll recognize, the authorization token and the host name and some of the things that you saw Clemens show when he was talking about programming against the cache. These are config characteristics for each of the items that are used within my application. So now I kind of have an overall view of what's actually included in my application. If I go and right-click on this, I can go get a diagrammatic view of the application. Now I'm also seeing what are all of the dependencies among my applications. So now I get the view that shows me here's my web front end, here's some of the key config characteristics of that, communicates with a service that interacts with the service bus and with cache information. Here's my SQL Azure usage from the ASP application and so on, right? So I'm kind of getting this view of this application as well. Now, this app file is not only containing what are the piece parts of my application, the config information, it also contains this dependency information. So now, after I've built out my application, I can go and say that I want to publish this application. So rather than me going through and what is my separate sort of steps associated with configuring and publishing the information up to SQL Azure, how do I push that DAC pack up to SQL Azure, for example? How do I go set up the cache and all the space that I need in the cache? How do I go push up the ASP app up to web roles? How do I go push my WCF services up to a worker role, for example? You notice I didn't have anything in here in terms of web and worker role definitions and so on. I was just describing the nature of the application itself. When I go to publish that up to AppFabric, I'll put in the information here associated with my comp app namespace. So just like you saw Clemens go and set up a namespace for service bus and cache, I can go set up a namespace for this AppFabric application. I'd put that information in here and I could publish that up to AppFabric. I have this application pre-provisioned up on AppFabric, so I can go up to the management console now that's pointing it against one of our test environments for AppFabric. I can see a set of applications that I have deployed up here. Benefits app is one of these applications. I can click on that, and I'll see a few things here. One is I'll see that I have that same representation of what's in the application. I see some core information here around the root URI of the application. If I scroll down here, I can see that I can get a list view of the application. This is going to show me some of the URLs associated with the piece parts of my application. So I had that WCF service. I could click in here. I get that same kind of WCF, WSDL page representation of the service. I can click over, see some core monitoring stats associated with that. So if I click over to the 24-hour view here, I should see a set of management or monitoring stats that come up. So now I'm getting monitoring stats off of the ASP front end. I'm getting information associated with the calls to the cache, calls to the SQL database, to the WCF services. So I get one view for the entire application of all of the key monitoring aspects associated with that application. I could come in here if I navigate back to my app here. I'll have a bunch of config information that I may want to set on that application. So for each one of the services, I could go and configure specific information associated with that service. So there's my WCF service. I might want to go in and set scale characteristics, right? So I had some default scale characteristics associated with a service. I can jump down here and say that I want to scale out my web front end or my WCF mid-tier out to a different level. So I can set a scale out count associated with parts of my application. So I get this single view of the entire application. Can do management monitoring against that single view of the application up in the console here. So I'll stop there. Again,
if you can go and show me that little graph again.
Yes.
So there's one thing that was enormously painful when we were building out all this cloud infrastructure, and that is knowing where everything is. What you're giving us with this information, this is not only to build a diagram. What's important is we now, with you giving us these service endpoints and service references, we now know the structure of your app, which means we can deploy all those pieces, and now we can give you a resolver that actually knows where we deployed all those things. So you don't write the humongous config files that say, here's how the layout of my app works, and this piece lives here, and this thing lives over there. We're actually generating all that deployment information as we're deploying the things out, and we have APIs for you to pull that config from the deployment system in. So that's a significant amount of work that we had to do as we were building our services, and that this modeling-driven approach is now helping us with. So that's absolutely fantastic.
That's right. Yeah.
Thank you for showing us that.
You're welcome. Thanks very much.
So this is going to be fairly interesting, and it's going to be still going to be a long journey. We have all intent, without giving you a day or date, but we have all intent to make this available as a CTP fairly soon. Or did we announce it? I think we announced that yet. Did we announce it already? Did we say as soon as June? So as soon as June. So you're going to have that as soon as June to play with. This is it's a journey, right? So in the beginning, you will be tuning your instance counts yourself. However, you will see, since this is running as a high-density solution on a sub-VM level, right? We own the VMs, you own the services. If you increase your instance count, it's going to be it's almost instant. Deploying your application is going to take a minute instead of 20. So because we're building high-density infrastructure that's not VM-based but sub-VM-based, we can create some really interesting things. And in the future, because we know what the layout of your apps is, we can go and start adding things like autoscale and automatic sensing of what this is. So it's a journey that we're starting on. We don't expect to release this into production this year. So this is something we want to have feedback on, and we're keen to get input on how useful that is. So next month, you're going to get that. So roadmap, things we checked off are access control and caching and service bus. The new CTP are all done. Application manager is pending, coming next month. And then access control is going to have a refresh in the second half. Caching is already available. And service bus is going to come out with the queues and the topics. We're going to do that this year. And then the application manager is coming out with a new refresh, so that's the piece that you just saw. And we're also going to add integration, which I didn't talk about now, but which will be an added feature set, a brand new added feature set to service bus. We're going to add that as well, and that's going to give you capabilities that are built by the BizTalk team for integration capabilities. So with that, this is what we had. I hope that was interesting as an overview of all the pieces. I would encourage you to go to Jürgen's session tomorrow. At what time is it? At 1:30 in what? Do you know where? So it's tomorrow. I think I have the session code somewhere. There it is, COS 311. Is that right? Yeah. So I encourage you to go. C208 on the other side of the world, and I would encourage you to go and watch that session so you can go and see this. We built this as the new middle tier. This is a brand new set of middle tier infrastructure. There's a lot of exciting stuff in there. A lot of things coming. We're hard at work to getting those capabilities out. We're releasing them as we can, so you see a growing platform with cache already out, access control already out, service bus already out, where we're keep adding new features as quickly as we can. And we're going to build this also for the server over time. We do cloud first because that's the way how we can build scalable services. And with that, if you have questions, you can come here or ask me also on Twitter. I'm at ClemensV, or please go to our forums. So thank you very much for your attention.